the coordinate plane. We're going to be rotating. That means just moving things around, okay? Certain points. Now, I have some vocab words, and I have 3 vocabulary words that are coming up. And what I want you to do is I want you to leave a little space in between these vocab because I'm going to talk about some of these things, and I want you to maybe jot some things down for each one, okay? You know what? You might in your homework a little bit, but not in For your homework, you could probably just use graph paper today. It'd make your life a lot easier just to use graph paper. You don't even have to use lined paper. Okay? So rotation, angle of rotation, center of rotation. Yep, I'm going to fly through this. I'm hoping to have a test already on like Friday. This Friday? I might skip a few lessons in this chapter actually, so. Yep. I might have already skipped one. I think I'm going to skip another one coming up. Not that I don't think it's important. I think it's something you need to know because it's just new to you. But I also need to get to something else too this year yet. So, like volume and surface area and stuff. And I still need to get a little bit of that in, because otherwise you won't have it again till geometry, and I hate to do that to you. I'm trying to make sure you have the easiest transition as possible, and I want to make sure we at least have some knowledge of some of these things. Probably not. No. Nope.
You're saying that you know?
Rotation, angle of rotation, center rotation. Rotations.
Well, yeah, we saw Mr. K.
Still Mr. K. Nothing's really different. Nothing's really different at all. You still have Mr. Kerneisel. You can still do everything you want as a freshman. I mean, there's really nothing that's too different about it.
No, but you won't have to take calculus.
You'd be
The better deal.
You'd be 2 whole sections behind the few.
Not necessarily. When you get to junior year, usually if you follow the track like Algebra 1 or Algebra Geometry, Algebra 1 or Algebra 2, you still will have time to get all of that in. I mean, as a senior, you have an option to take a different kind of math then. But if you would take pre-algebra your freshman year, you still have time to get Algebra 2 in, because that's what colleges want anyway. You still have plenty of time to do that. So.
Then you might have to take pre-calculus senior year.
Pre-calc, or there's other math classes we do offer. It'd be hard not to have a math class on junior year. So, all right. So rotation. Let's talk about the first thing here. Rotation. One thing you need to know, because this is really important today, they're going to talk about clockwise and counterclockwise. And you have to know what each of these are. Clockwise is this way. Counterclockwise is the other way. Some people don't know this. Some people get confused. If you do not know, think of the clock. Clockwise is the way the clock moves. Okay? Counter is the opposite. So make sure you know the difference between the two. Angle of rotation. Today, they're going to ask you probably to rotate things about 3 different ways. They're going to say rotate at 90 degrees, rotate at 180 degrees, and rotate 270 degrees. Those are the basics. Okay? But they're going to say, like, rotate 90 degrees clockwise, rotate 90 degrees counterclockwise. Okay? 180, they're not going to say counterclockwise or clockwise, because no matter what, you're going to end up in the same spot. Okay? 270, they're going to say clockwise or counterclockwise. Okay? Center of rotation, this is really important. Today, they're going to ask you to rotate around 2 different things. They're going to ask you to rotate around the origin, and they're going to ask you to rotate around a fixed point. For example, they'll say like vertex A. Okay? So it's important to read your problems today. So like, for example, around the origin, I'm just going to draw some coordinate planes here so you can kind of see. Origin is right here. That means whatever you rotate is going to be rotated around this. So for example, let's say it says rotate this around the origin 90 degrees counterclockwise. Well, if you do, this is how it's going to look. Okay? Pretend that looks good. Ugh, that's bad. Kind of, yeah, like one section. Yep, 90. Yeah, so if you are rotating around the origin, yeah, you're going to end up in a different quadrant. Okay? So if I do 180, it's going to look like this. Okay? But I know, it's been really off today. That would be 270. Now, if I'm going to do around a fixed point, that's different. Okay, so let's say I have another triangle, and this is my point right here, and I'm going to say rotate around vertex A. That means A is going to stay where it's at, and you're going to rotate it around that dot right there. So when you rotate around a fixed point, it doesn't mean you're going to end up in every quadrant. Okay? It just means that you're going to rotate around this point only. That point's going to stay, and that's going to rotate around it. Okay? So around the vertex or a point, it's just going to be one of the points on the picture or on the, I don't know, what do you call it, shape. Here, it's actually going to be around this, so you're going to end up in a different quadrant every time. Okay? So two different things. Now, I have a lot of rules for rotating around the origin. It makes your life a lot easier. Okay? So, this is all of my rules. So seriously, trust me, okay? Trust me. Your book does not have them, so you have to write them down. Your book does not have them. No, not going to print it off. This is for the origin only. This is not around a fixed point. No, and I'll explain why not. If you need me to move it, I will move it up for you. And I will talk about all these in a second. So.
Is this supposed to be degrees?
Yep. You mean the little asterisk? That's degrees. Yep. And I will actually move it up now because there's a lot. There we go. This is the end. That's it. Oops. Let me know what you want me to do, if you want me to move it up or down. Thing called asterisk thing? Rule. And then my last one's probably example. Yep. I'll show you why. Yeah, because at 270, follow 90 degrees counterclockwise rule. Then you go to the 90 degrees counterclockwise and do that rule. Right? So like if it says rotate my figure 270 degrees clockwise, okay, here's the rule. Oh, follow 90 degrees counterclockwise rule. Then I have to come down here and do this one. Okay? And I'll show you why that is in a second. Some of you are like, well, that's confusing. It's really not. And I'll show you. I'll even demonstrate. I'll even show you a demonstration. We'll do some examples of these after I show you why some of these work. That's it. It goes from 180 to 90 degrees counterclockwise. Oh yeah, I spelled that wrong. Counterclockwise, that's funny. It's funny, nobody in my other class even said anything. I'm surprised. Nobody giggled. Is that why you were giggling before? Kenzie was giggling before. Why is she laughing? Yes, I will. Is that good? Oh my gosh, you guys. You're all so difficult. What equation? Like this? Okay, then I'll move it back down. Are you good? Okay, then I'll move it down. Is that better? What's the matter? Yep. Okay. Are you guys good? Are you guys good?
Sure.
No?
Yeah.
Just go. Okay, I'm going to talk about why the 270s are the same as the 90 degrees ones. Okay? So let's pretend this is the origin. And I'm going to rotate myself 270 degrees clockwise to you guys. To me, it'd be, it's still clockwise, right? It's clockwise to you too, right? Okay. So I'm going to rotate myself 270 degrees clockwise. Okay, so first of all, here's 90 degrees clockwise. Here's 180. Here's 270. Okay? This is where I started. Now, if I go 90 degrees counterclockwise, wouldn't that be the same as 270 degrees clockwise? Do you see that? That's why I have the rules set up like that. So if you have to go 270 degrees clockwise, that's why you can follow the 90 degrees counterclockwise. Okay, yeah, because it's the same thing. Same thing. 180 degrees, notice that they didn't ask you to do counterclockwise or clockwise because you're going to end up in the same spot. If I go from clockwise or counterclockwise, I'm going to end up over there. If I go counter, I'm going to end up this way. Okay, so it's the same thing. 90 degrees clockwise, these are a little confusing, aren't they? So what you have to do is using your rules. Seriously, the other class is like, I don't get why you got to do this. I'm like, use the rules. That's why I'm giving them to you, okay? And we'll do some examples of these next so you can kind of see how they work. Is that all right? Now here's the deal. Around the origin are the only ones that have rules like this. And the reason is because we know this is going to be rotated around 0, 0. That's the only reason that we have rules for this. If I have a fixed point, do I know what point I'm going to be rotating around? I have no idea. Well, yeah, they're going to tell me, but I don't have any rules that can figure that out. Okay? So that's why I have rules for around the origin, and I don't have rules for around a fixed point. Okay? And I'll show you a fixed point in a second. I'll show you an easy way to do those. Questions so far? Okay. If you want to go, go. I'm going to do an example. Okay? So here's my example. Here's my old one. Oh my gosh, this is terrible. My originals. Okay? And it's telling me I'm going to do what? Rotate it what? Okay, so find your rule. Find your rule. I think it is you have to multiply something by -1 and then switch them. Okay, so we're going to multiply x by -1 and then we're going to switch. So I'm going to do this a little bit at a time so we don't get confused. So the first thing I'm going to do is I'm going to multiply by -1. So my A would be 4, 3. My B, if I multiply x by -1 times -1 is 1, 1. And it'd be 4, 1. Now I'm going to switch. See how I'm doing it in sections so I don't get confused about what I'm multiplying and stuff? So now my new one's going to be 3, 4. 1, 1's going to stay the same. 1, 4. Then this would be my new one. If I would regraph this, if I would graph this one, and I would graph this one, this would actually be the 90 degrees, counter or clockwise rotation of this new one. Yep. They might, but they're going to give it to you on a graph. They're going to have you graph it out because that's the easiest way to do it, and I'll show you that in a second, okay? So do you understand what you're doing? You got to follow your rules. So let's do another one. Do this one for me. You do this one this time. You do this one. Follow the rules. What are you doing? So I think this one is counterclockwise, so I'm guessing you multiply y by -1 and then switch. Remember, this is, yep, so remember this is only for around the origin you can use these rules. Let's see, so let's do y times -1 first, and then we will switch. So y, so that means this column would be multiplied by -1. So it would be 4, -4, 4, -1, 2, -1. Are you guys ready for the next part? So then it would be -4, 4, -1, 4, -1, 2. Have any questions on this? Okay, so let's say I gave you these right here, and I said rotate it 180 degrees. What's the rule for rotating this triangle 180 degrees? Yeah, here? Okay, so for this one, it would be -4, -4. This would be -4, -1. This would be -2, -1. That would be if you're rotating around, or just rotating 180 degrees. Any questions so far? Everybody understand how to use the rules? Okay. Next part I want to discuss is around a fixed point. Now here's the thing. You're probably going to have to graph it because that's the only way you're going to be able to see it on a graph. If they give you the points, you don't have any rules. You have to actually see it on the graph to be able to rotate it, okay? So let's pretend this is my figure right here. And I want to rotate that. I want to rotate that around point A. That's my point A, okay? Here's the easiest thing to do. Graph it, just like what I have up here. Figure out what you're rotating around, and then create an origin around it. Create a new coordinate plane. Do you see what I mean? Okay, pretend that's the origin. Then, you still can't use the rules though, sadly. So let's do this 90 degrees. Let's do counterclockwise. Okay, so I'm going to take this thing, and I'm going to rotate it. Pick a line. I would pick this bottom line and rotate it 90 degrees. So where's the new bottom line to that thing? Right here. Okay? Then if I rotate it 100, what is going to happen here? Where's my point going to be? See that? Okay.
I don't even know the exact point.
The exact, what do you mean? They'll tell you. They'll tell you around vertex A. I just made that my vertex A.
But like, how do I know that that's what the triangle is?
Well, if I look here, I know it goes through 2 boxes.
Okay.
Goes through 2. You got to just kind of think, okay, if this is, it's not going to be this big. Okay, right? You have to kind of use some common sense and think, okay, if it goes up to 2 lines, I know that's where my edge has to be. Okay? Now let's say if we need to rotate it 180 degrees from here. So that's 90. And then I'm going to rotate it again for 180. So this, yep, it's going to be upside down. And that's going to be 180 around that point. I'm going to rotate it 270 degrees. Let's see. It's like 90 degrees backwards, so it'll be like this. Okay? So honestly, you have to think about this. This is the part you're going to actually have to think about is around this fixed point. Seriously, graph it. Graph the old one. Make up your origin and then help yourself figure out where it should go next. That's seriously the easiest way. I honestly have no other way to teach it to you because that's the easiest. Create, you know what I mean? Create your own coordinate plane, pretend it's the origin. Seriously, you can turn your paper, sketch something out. If that doesn't look right, start again. It's okay to do that. Okay? Do you guys have any questions for me? I have one more thing I need to show you. Okay? One more thing. It's called rotational symmetry. Okay? This is actually pretty simple, but it takes a little thought. Rotational symmetry. If a figure can be rotated less than 360 degrees and match the original figure. And I might actually have you get your book out because I have better examples in your book. A figure can be rotated less than 360 and the image will match the old one or the original figure. And actually I might have you open your book. I'm not sure what page it is. Actually, I do. Page 530 in your book. This is the easiest way to show you. 530. And I'm 530. 530. And I'm going to have you look on the bottom under example like 4. Number 4.
I'm not good at drawing stars.
You don't have to, just do your best. Seriously, do your best. I don't care. Okay, so example 4 talks about rotational symmetry, and it shows you a snowflake. Do you see the snowflake? Okay? So on that snowflake, see how you can turn that snowflake just a little bit, and it'll match up with what the figure should have been in the first place?
Yeah.
Do you see how you could just like turn it a little bit, and it'll match, turn it a little bit, and it'll match, turn it a little bit, it'll match? Do you see what I'm talking about? It even has 6. 1, 2, 3, 4, 5, 6. You could turn it 6 times, and it would match up 6 times before it got back to the original figure.
Okay.
Do you see that? That's rotational symmetry. It should be able to match up on itself before you get back to 360 degrees. So if I look at my smiley face, does that thing have rotational symmetry? No, because I'm going to have to turn it the whole way around until it gets back matched up on how it was. Okay? That's why I kind of have that snowflake up there too. Don't look at the little guys, little snowflakes. But I could turn this actually 1, 2, probably 3 times before it would show up back to the original spot, right? Because are these two things, oh, they're pretty close to the same, but I would say this one and this one are close to the same, right? And this one and this one, ooh, this one and this one. This one and this one. Pretty close to the same, right? So if I pretend they're all the same, how many times would I have to turn it? Is it 1, 2, 3, 4, 5, 6, 7, 8? Yeah, 8 times I could turn it before I got back to the original figure, and it'd have to match up perfectly though. Then I might ask you, what's the angle of rotation? How many degrees do I need to turn it so it matches up the first time? Well, that's pretty simple. You take your 360 and divide it by how many times it would take you, divided by 8, and that will give you the degrees. So even if I look at number 4 on the, see on the bottom there with that orange flower? See that orange flower? So how many times can I rotate that before it gets back to the original figure? Just 3. 1, 2, 3. So you take 360 divided by 3, 120, and that's how many degrees you need to rotate to the perfect. You guys know what I'm talking about? What? Well, divide by how many times you would need to turn it. Yeah, it's number 4. So, rotational symmetry is just how many times you can if you can rotate it so it matches up like the original figure before you get it back to all the way around. What's that? Okay, so yeah, this one for number 4 it'd obviously be 90 degrees. Because there's 4 different times you'd have to turn it to get back to the original, right? 360 divided by 4, 90. Okay. Let's look at your homework. Okay, because I want to talk about this. I'm going to shut this off.